Have you ever wondered why atomic mass of chlorine is 35.5 and not a whole number? Or how chemists figure out the mass of a molecule without using a scale? In today's video, we are breaking down two essential concepts in chemistry: relative atomic mass and relative molecular mass. You learn what they mean, why they matter, and how to calculate them using real examples. No stress, just clarity. And this topic is very important for your moles concept as well. Now, if I'm talking about finding the atoms in a compound, for example, if I say sodium chloride, okay, NaCl. So sodium chloride has two different types of elements, sodium and chlorine, and each element has one atom only, right? If I'm talking about 2 NaCl, so I'm putting a coefficient in front of the compound. This means I have two molecules of sodium chloride. This means I have 2 sodium and 2 chloride, right? Now, if I'm talking about a compound, let's say NaHCO3, sodium hydrogen carbonate. In this, how many elements are there? 1, 2, 3 and 4. So I have 4 elements: sodium, hydrogen, carbon and oxygen. Let's talk about number of atoms for each element. Sodium I have 1, hydrogen I have 1, carbon I have 1 and oxygen I have 3. This subscript tells us number of atoms of that particular element. You get my point? One more type of question which you should know, and that is Al2CO3. So this is another type of question. In this aluminium carbonate, how many elements are there? So you will say Al, C and O, right? Now in terms of number of atoms, I have 2 atoms of aluminium, I have 3 atoms of carbon, and I have 9 oxygen. How? Because this will multiply by the carbon inside the bracket. So if there is no number next to the element, it is considered as 1. So 3 ones are 3 and 3 threes are 9, because this 3 will multiply with this one. So 3 threes are 9. So this is your answer. It has 3 different elements and each element is of these many numbers. I hope this is clear to you. Relative atomic mass is the average mass of atoms of element compared to 1/12 the mass of carbon 12 atom. Now earlier scientists used carbon 12 as the sample, as the value to compare the masses with other elements. So they used carbon 12 as a base value. Okay. In simple terms, what I will say is the relative atomic mass, or in short AR, tells us how heavy an atom is compared to carbon 12. Okay, it has no units. It takes into account of all natural occurring isotopes and the elements and their abundance. So if you are going to talk about AR is basically the average masses of all the isotopes which are present for a particular element. Just for example, if I say chlorine 35 is 75% present in nature and chlorine 37 is 25% present in nature. So I'm talking about chlorine 35 abundance is 75 and chlorine 37 abundance is 25. So how the relative atomic mass can be calculated? It can be calculated using a formula which is the isotope times its abundance plus isotope second times its abundance upon 100. Getting my point? So how we can calculate the AR? AR is the isotope times its abundance plus isotope second times its abundance upon 100. So if you see, chlorine 35 is how much present? It's 75% present in nature, and chlorine 37 is 25% present in nature. You just put the values in the formula and you will get a value of 35.5. This is the AR of chlorine. So if you see the atomic mass of chlorine, it's 35. How you got 35? This is the method. So I can compare and I can say that the atomic mass of the element is same as the relative atomic mass, with a slight difference in the meaning and usage. So if I compare the atomic mass with relative atomic mass, you will see that relative atomic mass is the average of all the isotopes of elements present, right? So the term is relative atomic mass, and when we use this term as relative atomic mass, we are just talking about the average mass of the element. So when I am talking about atomic mass, I am talking about number of protons and neutrons in an atom. But when I am talking about relative atomic mass, I am definitely looking into the average mass of all the isotopes of the element present. And now this, I have shown you a method how to find out the AR of n of any element. So you will be getting the values, and you have to just put the values in the formula and you will get the AR of the element. But AR is already in the periodic table. So for example, if I ask you what is the AR of sodium, so you will open the periodic table and you will say it's 23. Or if I ask you what's the AR of oxygen, 16. AR of iron, it's 56. So to cut short and make things simple and easy, AR is same as the mass number, but we should be careful where we are using these words. You get my point? If you are talking about the atomic mass in context with atomic structure, then we're talking about protons and neutrons. And when we're talking about relative atomic mass, we are definitely talking about the isotopes of all the elements present, their average mass. I hope this is clear. Now, when we talk about MR, we just need to add up all the ARs of the elements and the number of atoms given in the question. So let's see some examples how to work on this AR and MR. I have a question that says HNO3, and I want to find the MR of this compound HNO3. So what I need to do is I need to first look into how many elements are there in this compound. So there is hydrogen, nitrogen and oxygen. The next thing what I will do is I will look for the number of atoms for each element. I have 1 hydrogen, 1 nitrogen and 3 times oxygen. Then I need to just find their AR from the periodic table. Hydrogen is 1, nitrogen is 14 and oxygen is 3 times 16, right? Now I'll just use my calculator and I'll just solve this. So 16 times 3 is 48. So 48 plus 14 plus 1 gives you 63. So the MR of this compound is 63. Are you getting my point? Now next type of question, if you see, CaOH2. In this I have 1 calcium, 2 oxygen and 2 hydrogens, right? So I can write like this also, Ca plus 2 times oxygen plus 2 times hydrogen. Calcium is 40 plus 2 times 16 plus 2 times 1. 40 times 32 plus 2. So if you add them up together, it will make up to 74. This is your MR for calcium hydroxide. Clear? Another type of question. Let's say CuSO4.5H2O. This is hydrated copper sulfate. In this, there is 1 copper plus 1 sulfur plus 4 times oxygen plus 5 times water. Okay. Now, if you see water is H2O, so hydrogen is 1, so 1 times 2 plus 16, it's 18. I will look for the mass of copper. So copper is 63.5 plus sulfur is 32 plus 16 4s are 64 plus, now in this case there are 5 molecules of water. So you do 5 times 18, you get 90. Now you add them up together, you get 248.5. This is your MR for hydrated copper sulfate. So I have covered different types of questions. I hope you got the idea of AR and MR.